Welcome back to the show, everyone. Today we're diving deep into the fascinating world of software development, specifically exploring a tool that many of our listeners might not have heard of, a Mixin framework. Now, if you're not familiar with what a Mixin is, you're in for a treat. Imagine you're building a house. You want to add a new room, but instead of starting from scratch, you can simply plug in a prefab section that fits perfectly into your existing structure. That's kind of what a Mixin does in programming. It allows developers to inject new behavior into existing classes without altering their original structure. So, over the years, this Mixin framework has undergone a lot of updates. Think of it like a car that's continually being upgraded with the latest features. The changelogs we have here are like snapshots of that car's evolution. For instance, back in January 2020, we saw an upgrade to support Java versions 9 and 10, which is significant because as Java evolves, so must the tools designed to work with it. There were also dramatic improvements to context reporting during this update, which helps developers pinpoint where things are going wrong when an error occurs. Debugging can sometimes feel like trying to find a needle in a haystack, but improvements like these can make it feel a lot more like finding a light switch in a dark room, so much easier. In September 2020, we had a hotfix that addressed a critical issue related to mod launcher support. It's a prime example of how software development is a balancing act. Developers need to keep everything functioning smoothly as new updates roll out. This hotfix improved how the system resolves obfuscated members in inherited interfaces, which is one of those behind-the-scenes tech things that can make or break a program's reliability. And let me tell you, the iterative nature of software development is not just about bug fixes. Each version adds layers of functionality, like adding upgrades to an app on your phone. One interesting addition from the later iterations is the dynamic target selector. This essentially gives developers more flexibility in deciding how and where these mixins are applied, which opens up numerous possibilities for customizing behavior in ways that weren't previously possible. How do you think this level of customization changes the landscape of software development? Do you think it makes it more accessible for new developers or creates a steeper learning curve? Now, here's a fun fact. The framework has even grown to support annotations like @coerce, @overwrite, and dynamic. Imagine being able to sprinkle a bit of magic dust. These annotations transform how developers can manipulate existing code, enhancing readability and maintainability. It's like having a Swiss Army knife with all the tools at your disposal. Before we wrap up, let's acknowledge the immense community that contributes to projects like this. The notes from June 2016 mentioned the support for async decompilation, a feature that shows how the community responds to evolving needs. It's truly a collaborative effort, and it's inspiring to think about how these contributors come together, sharing knowledge and expertise. So, whether you are a seasoned developer or just starting out, there's always something new to learn in this field. If you're curious about the nuances of Mixin frameworks or how advancements in software tools impact your projects, I encourage you to dive into those changelogs yourself. They're like a roadmap of innovation. We'll continue to explore more on this topic, but for now, a moment to consider how these advancements might influence your own work, from debugging to feature creation. Until next time, keep coding and stay curious.